All right, Geometry, today for 2.8, we are going to review some things that you should know from last year in Algebra 1. So we're going to look at slope and equations of lines. So there's two objectives for today. We're going to write equations of a line given info about the graph. And then number two, we're going to solve problems by writing equations, specifically linear equations. All right, so let's review this. Slope. So if you guys remember, slope is just the change in y over the change in x. Okay, so there's a couple of ways that we could write that. One of the ways that you'll see is this, where we have delta y over delta x. That means change in. Okay, this is the same thing as y2 minus y1. Okay, y2 minus y1 over x2 minus x1. Okay, so if you have coordinates like, I don't know, 3 comma 0 and negative 1 comma 6 or something like this, if you wanted to find the slope between those, you could just use these points, right? So this is x1, y1, x2, y2. All right, and you could plug those things in here and find the difference in the y over the difference in the x. Okay, so that's a reminder from slope. A couple of other things to consider is whenever you have a horizontal line, notice this is the y-axis, this is the x-axis. If you have a horizontal line that goes through here, right, we'll call it this one right here. The equation for that horizontal line will always be the y value, because this line always has the same exact y value. It's whatever this y value is here. So if we wanted to call it 1, 2, 3, we would say the equation for this line is y is equal to 3 always. There's no variable x because no matter what you plug in, you're always going to get a 3 out, right? So this is a constant equation. There's no x variable. Then for the vertical equation, okay, same logic. If you have an xy coordinate plane, and this is y and this is x, then your vertical equation will always be wherever you go through the x, because x won't change. So if we did x equals 3, it would be this guy, where it's vertical going through 3. So the x value will always be 3, right? So forget this. This is going to be x equals 3. And if you were going to draw that example, x equals negative 1, which maybe I should put that one down there just in case, because that might be in your notes. But at negative 1 here, right, it would just be this guy, vertical line through negative 1. All right, so that's vertical and horizontal. Notice here, you guys, for vertical equations, they don't pass the vertical line test, right? So these are not functions. So typically we call these slopes, another name that we have for these slopes is undefined. Has an undefined slope if it's vertical. If it's horizontal, the slope will be 0. And that's because the change in y will be 0 over the big change in x. You know, whatever the x change is. It could be 3 or whatever, I don't know. But a horizontal slope equation looks like this. A vertical slope equation looks like this. And you can never divide by 0. If you try to divide something by 0, you'll get something that's undefined or an error message on your calculator. So we're not going to call that a defined slope. We're going to say it's undefined. Okay, so when the slope is 0, let's take a look at that in depth here. So if you have 2 points, these 2 points are negative 2, 6, and 5, 6. Notice that the y values here are going to be the same, right? So the change in y is going to be 0, because 6 minus, well, I'll show you the whole thing. So we have 6 minus 6 over 5 minus negative 2. 6 minus 6 is 0. 5 minus negative 2 is 5 plus 2, which is 7. 0 over 7 is just equal to 0. So I know that this is a horizontal line. Okay, so since the slope is 0, and be careful when you go the other way and if you get 0 in the denominator, that is not a slope of 0. But look, at 5, let's just call this 5. At 5, 6, we have a point. And then at negative 2, 6, we have a point. Notice if we connect those two things, it's a horizontal line through 6. Okay, so example 1 says Find the slope of these various situations. So all you're going to do is practice plugging this into your slope equation. So we're going to do y2 minus y1. Okay, so I guess you could just always, it doesn't really matter which one you choose is 2 and 1, but I always just choose the second one because it makes sense. But y2 would be negative 5 minus y1, which is minus negative 2. Okay, be careful with the double negatives. Over negative 3 minus 6. Negative 5 minus minus 2 is negative 5 plus 2, which is going to come out to negative 3. Negative 3 minus 6 is going to be negative 9. A negative divided by a negative is a positive, and 3/9 reduces to 1/3. So example 1, first slope there is going to be 1/3. Then we go on, maybe I should change the color here. Going on to B, so we did negative 2 minus negative 3 over negative 6 minus 8. That's negative 2 plus 3, which is 1. Negative 6 minus 8 is going to be negative 14. And I am done. Okay. I'm going to go ahead and let you do part C and part D on your own. Okay, so we'll pause the video here and let you do that on your own. And now let's just take a look at it and make sure that you did it correctly. So here we go. So we have negative 3 minus 2 over 4 minus 4. Notice in this one we'll have negative 5 over 0. Whenever you divide by 0, the slope is undefined. So hopefully you didn't say the slope was 0. Hopefully you said it was undefined. Good practice there. And then for part D, notice what we have here. We have 3 minus 3 over 4 minus negative 3, which is 0 over 7, which is 0. So the slope is 0. All right, moving on. So we have non-vertical line equations. We remember this from Algebra 1, that you can have a slope-intercept form, right? Y equals mx plus b, where m is simply the slope. So m is equal to the slope, and the x and the y are any xy on the line. So some people don't get that for a while, and that really throws them off. But if you have a line like this, if it goes through, any point that it goes through can be plugged into this equation. Okay, so if we had a line here, let's just say 2, 3 is on the line, right? You could plug the point 2, 3 into this equation. It has to work in this equation, where 2 is the x value, 3 is the y value. Okay, so just so you know, this x and the y represents any x and y that's on the line that we're talking about. And then we have point slope form, which may be a stretch for you to remember, but this is just y minus y1, it should be sub 1 there, is equal to the slope times x minus x1. All right, so if you knew a point and a slope, you would plug it in for the x1, the y1, and the m, right? So let's just practice that really fast. So if we have a slope, let's just say we have a slope that is 2, and it goes to the point, I don't know, 0, 8. Okay, so if that's going to happen, actually we should do a negative here. Let's say negative 1, 8. How about that? Okay, so if this is what's happening and we're going to plug it into this form of the equation, notice what happens here. We have y minus the y value, which is 8, is equal to the slope, which is 2, times x minus the x value. So it's x minus negative 1, which is going to be x plus 1. All right, so we can rewrite this as y minus 8 is equal to 2x. Notice this is going to be 2x, 2 times x here, and then 2 times positive 1. That term's positive there, so 2 times positive 1 is just plus 2. And if we simplify this and solve this for y, it'll be in slope-intercept form. So if I solve this for y, I could say, okay, plus 8 to both sides here, and I get y is equal to 2x plus 10. I know that my slope there is 2, my y-intercept is 10. Okay, so that's just an example. Let's try one now. So it says, example 2, write an equation in point slope form. So they don't want you to reduce it here at all. They want you to leave it in the point slope form of the line with slope 4 that contains negative 3, negative 6, and then graph it. All right, so y minus y1, which would be negative 6, is equal to the slope 4 times x minus x1, which is negative 3. Let's rewrite this and get our signs correct here. So we have y plus 6 is equal to 4x plus 12. All right, they want it in this form, so don't try to reduce this. Okay, so we can circle this, but if it helps us, well, it probably won't help us much. If we can graph this pretty simply without the equation, we can put a point at -3, -6, right? -3, -6 is right there, I believe. And then it says the slope is 4. So change in y, 4. Change in x, 1. So it's going to go up 4. It's positive. 1, 2, 3, 4 over 1. Then we'll do that again. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So we have this line right here. And we're done. Okay, that's example 2. For parallel lines, you guys, anytime you have parallel lines, if the lines are truly parallel, okay, so if you have truly parallel lines, mine won't be because I'm not using a ruler or anything here, but they look parallel-ish. Okay, anytime you do have parallel lines, notice what happens here with slope. The slope, the change in y and the change in x is going to remain the same. So the slopes will always be the same. Make sure this is in your notes with parallel lines. With perpendicular lines, if you were to draw perpendicular lines, those are lines that meet at a 90-degree angle. Okay. So notice here, if you have a line going through here, and then you have a perpendicular. So say that we have this line right here. This is going to be a positive slope, right? From left to right, it's going up, and then and it has a certain rate of change, right? And then we have the perpendicular to it, which meets at a 90-degree angle. Notice that the slope would have to be the exact opposite, right? Everything has to be the opposite here. So for this to happen, the product of the slopes between them will always be equal to -1. And to get that, you basically just flip and switch the slope. So the slope will be inverse with the opposite sign of the line given. Okay, so if we started with something like, I'll use this example down here. If we started with something like y is equal to 2x, right? The perpendicular line to that would be the flipped, switched version of this. So if you have a whole number, remember that a whole number can be divided by 1 and remain the same, right? So 2 divided by 1 is just 2. Okay, so if I flip that and switch the sign, it becomes, I'm not going to say equal to, but it becomes, if I go perpendicular, it becomes -1/2, right? So the perpendicular to 2 would be -1/2. All right, so let's look at determining some relationships. So if we're going to do that, the first step is to find the slope. Find the slope of each line, which is the change in y over the change in x, and then compare them. If the slopes are the same, they're parallel. If the slopes are flipped and switched, they're perpendicular. That's it. That's the relationship between different lines that have some kind of crossing, or maybe they don't. Maybe they're parallel. Okay, so let's apply this now to example 3. So for example 3, there's no directions written on this slide, but I can look here in your textbook. And for example 3, what they want you to do is they want you to determine whether line AB here is parallel, perpendicular, or neither to line CD. Okay, so let's just figure that out. So we don't have to put a picture of this here, but we will. 3, 6 is here, and then -9, 2 is here. Okay, so there's one line is between that. And then we have C, which is at 5, 4, and D, which is at 2, 3. Okay, so they appear to be parallel, but they want us to prove it, because if the slope's off just a little bit, these things could cross somewhere down the road, and then they may not be parallel. So let's just prove it. So let's find the slopes of these. So we would do y2, so I'm looking at these two first, right, AB. I'm going to do y2, which is 2, minus y1, which is 6, over x2, which is -9, minus x1, which is 3. When I do this out, I get 2 minus 6, which is -4, Negative 9 minus 3, which is negative 12. I can reduce that and cancel the negatives there. 4 goes into 4 once, 4 goes into 12 3 times. So my slope is 1/3. Now let's do it for CD, and let's change the color. So for CD here, we'll do 3 minus 4 over 2 minus 5, which is equal to 3 minus 4 is negative 1. 2 minus 5 is negative 3. So I can get rid of my negatives there. I get 1/3. Turns out these are parallel. So you would write parallel, and you're done. Okay, so there might be another one like that. This is 3B. There might be a 3A on your notes. So go ahead and try that one out on your own. If you do have a 3A on your notes, you should be getting neither for your answer. So example 4, final thing here, and we'll be done, you guys, is an artist is using a coordinate plane to plan a mural. A red line on the mural is represented by this equation. A blue line on the equation is parallel to the red line and contains this point. Write an equation in slope-intercept form for the blue line. Okay, so we have a line. It's this thing. Okay, this represents our line. We need a new equation that has a line that's parallel, is going to have the same slope, and it's going to go through this point. Okay, so I'm going to show you how to do that in a couple of different ways. First way would be to do this. Set up your new equation. So we'll switch colors here. Y equals, we're going to have the same slope. Okay, but what we don't know is we don't know where this crosses. We don't know our y-intercept. So we don't know B. We have to find B by plugging in the point that we know it goes through. Okay, so we're going to plug this point in here. Okay, so let's just do that. So the y value is 6. The x value is negative 3. And then we're going to solve it for B. So we get 6 is equal to negative 3 times negative 3 is positive 9. So we get 9/4 plus B. Okay, so then we're going to subtract 9/4 from both sides. By the way, 9/4 is the same thing as if you took 4 into 9, right? You would get 2 and 1/4. Okay, so if we subtract 2 and 1/4 from 6, where do we end up? Well, if you subtract 2 from 6, you're at 4, and then if you subtract a 4th, you'd be at 3 3/4. Okay, so you could try that on your calculator as well. So my final answer here would be this. Y equals negative 3/4 x, and I just found my B, so I'm going to plug it back in, plus 3 3/4. Now, one thing that you might try with this is you might try to plug this into the point slope form. Okay, so I'm going to show you that method as well. You can choose either method that you want. The point slope form is this, y minus y1. Well, y1's given, it's 6, right? We're looking at this again, is equal to the slope. Well, we know the slope because that was given to us in the beginning. Okay, since it's parallel, it has to be the same. And then we have x minus x1. So x minus negative 3, which would be x plus 3. Okay, so notice if you plug it into this, you'll get the same thing, right? So y minus 6 is equal to negative 3/4 x. Negative 3 times 3 is negative 9. So we're just distributing this out, negative 9/4. Right, so then we can add 6 to both sides. And when we do that, we get the exact same thing. Sorry, 3 3/4 here. Okay, so you can plug it into either of the equations that you've learned today, and it should still work. So you'll do a number of these. If I said it was perpendicular to the line, you guys, if you were doing this whole thing and it said perpendicular instead of parallel, then you'd have to flip and switch your slope and do the same thing, right? So for the perpendicular, you'd have y equals 4/3 x plus b, and then you'd plug the point in and see if that works. Okay, so we'll do some more of those together in class, guys. That's it for this one. Hopefully it's mostly review for you. Catch you next time.